In this video, we're going to calculate the percent abundance of each of the following isotopes. We're going to use the example of bismuth, Bi, whose molecular or atomic weight is 208.98. We then have two different isotopes. We have 207 bismuth with an atomic weight of 206.98. And then we have 210 bismuth with an atomic weight of 209.98. So now to determine the percent abundance of each of these isotopes, we need to use a little bit of algebra. So the atomic weight of any element will be equal to the mass of each isotope by its fraction of that isotope. In other words, we'll take our mass of our isotope 1, whatever that is, and we'll multiply that by the fraction of isotope 1. We'll then take that and add that to the mass of isotope 2 and multiply that by the fraction of isotope 2. You can continue doing this for as many isotopes as you have available. In this case, we only have the 2. So next, we have several unknowns, these fractions of these isotopes. So we're going to replace those with some variables so we can more easily determine it. In this case, the fraction of isotope 1, we're going to say that's going to be equal to x. And then the fraction of isotope 2 is going to be equal to 1 minus x, because both of these, since we have two isotopes, by adding them together, their fractions, it should be equal to 1. So if you had multiple isotopes, say you had 3 or more, then you need to alter those equations to match accordingly. So now let's plug in those variables back into our equation. So we know that our atomic weight of bismuth is 208.98. That is going to be equal to our mass of isotope 1, which is 207 bismuth. That's going to be 206.98 times x. Let's do a dot here. That is going to be plus 210 bismuth, which is 209.98. And that's going to be multiplied by 1 minus x. All right, now we'll do some algebra, put everything into order. So 208.98 is equal to 206.98x plus 209.98 minus 209.98x. In this case, we're just using our algebra. We're going to multiply those together, and then we'll multiply this by each of our two pieces there. All right, now we can rearrange, add things together. We have two terms with x, two terms without x. So let's rearrange this equation, and this is going to come out to -1 is then equal to -3x. Now to solve for x, we know that x is equal to positive 1/3 or 0.33 repeating or 33.3%. So now we know that the fraction of bismuth 207, which is our, again, fraction of isotope 1, is going to be equal to 33%. So fraction of 207 bismuth is equal to 33.3%. Like I mentioned before here, we know that the fraction of isotope 2 is going to be equal to 1 minus x. So in this case, our x is 33%. 1 minus x, or 1 minus 0.333, turned into a percent. It's going to be fraction of 210 bismuth is equal to 1 minus 0.33 repeating, which is also equal to 0.67 or 67%. So the mass percent, or the fraction of isotope 207 bismuth is 33%. The fraction of 210 bismuth is 67%.